Students, now let us concentrate on the miscellaneous exercise in the chapter 6, that is permutation and combination of your NCERT book. There is a miscellaneous exercise and we are going to solve the problems from the miscellaneous exercise. Now the first problem reads like this. How many words with or without meaning each of two vowels and three consonants can be formed from the letters of the word daughter? Okay. Now, if you look at this word daughter, D-A-U-G-H-T-E-R. Then first of all, we will have to separate all the vowels from it. So first vowel which appears here is A, then U, right? And then E, correct? So there are only three vowels, A, U and E, because you know the vowels in the entire alphabet is A, E, I, O, U. Now A is there, U is there, E is there, but I or O is not there. That means there are only three vowels present in this. So three vowels. So there are three vowels present in this particular word, and then remaining are all consonants. Consonants are D, G, H, T and R. These are consonants, correct? These are consonants. Okay. How many vowels are there? 3. And how many consonants are there? 5, correct? So 3 vowels and 5 consonants. Now we want how many vowels? We want only 2 vowels. We want to construct a word which contains only 2 vowels, right? And it contains only 3 consonants. Okay, so 3 consonants. Okay. In other words, I can select any 2 vowels out of these 3 and I can select any 3 consonants out of these 5, correct? So therefore, the total number of waves in which vowels can be chosen will be what? Will be 3C2, correct? But these vowels and the total number of consonants that can be selected is nothing but 5C3. Now these are the selections, but every time when we select 2 vowels and 3 consonants, and there is no restriction on the way the consonants and vowels are to be constructed, right? So therefore, we will have to find out the permutations of these 4 5-lettered words, because there the letters will be 5, 2 plus 3, 5, and the later 5-lettered word can be permuted in 5 factorial ways, correct? Now, if you want to find out the exact number, then it's very simple. 3C2, as I said, whenever this number is greater than half of this number, you better reduce it to something else. So 3C2 is same as 3C2, 3 minus 1. So it is 1. Here also, this can be written as 5C3, but 5C3 is same as 5C, 5 minus 3. So it is 2 multiplied by 5 factorial. Okay. Now 3C1 is very simple. It is 3. 5C2 is easy to calculate. 5 multiplied by 4 divided by 1 multiplied by 2. And 5 factorial, you all know, is 120. Okay. So therefore, this 2 and this 4 will get cancelled. You get 2. So 5 3 is 15. 15 multiplied by 2 is 30. 30 multiplied by 120 is the final answer. 30 multiplied by 120. That gives you 2 zeros followed by 36. So 3,600 words can be formed exactly containing 2 vowels and 3 consonants, right? From the letters of the word daughter. Is that clear? So what we have done? We have taken a word daughter, we separated vowels and consonants, and how many vowels are there, how many consonants are there, and how many we want, right? So we first of all selected them. After selection, we get a 5-lettered words, but that 5-letter words can be permitted amongst ourselves in 5 factorial ways. That is how the problem is solved. And the answer turns out to be 3,600 words. So now, the second question is, how many words with or without meaning can be formed using all the letters of the word equation at a time so that the vowels and consonants occur together? Now here, the important statement is using all words. So this gives us the permission to use all the words, correct? And secondly, we want vowels and consonants together, right? So these are the important words in understanding this particular problem. Now, let us write the word itself. It is E. I will write the word equation in such a way that I will automatically separate vowels from the consonants. Now, E is a vowel, so I will write it here. Q is not a vowel, so I will write slightly up. Then U is a vowel, correct? And then A is a vowel, yes, A, E, I, O, U. T is not a vowel. I is a vowel, O is a vowel, right? But N is not a vowel, correct? So equation, so entire word is actually accounted for. So 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. So all 8 letters we have accounted. So how many vowels are there? Let us write them together. E, U, A, I, O. How many consonants are there? Q, T, N. And now there is no repetition of any word here, so it's very simple. So I have to use all the vowels together. That means they will appear like a one word only, right? So this is one word. This is one word. This one word will act like one single object. So this is one single object because they will act like a group. So this group is not ready to dissociate from itself, right? They stick together. And here also, this is one another group, right? This is also one single object. So total number of objects are how many? There are 2 objects are there. This is one object which will act like one object. This will also collection will act like a one object. So there are 2 objects. Those 2 objects can be interchanged among themselves in how many ways? 2 factorial ways. But nothing stops us from rearranging the vowels amongst themselves. So how many vowels are there? 1, 2, 3, 4, 5. They can be arranged among themselves. And since there are 5 in number, that can be done in 5 factorial ways. Similarly, nothing stops us from rearranging QTN in their own way as long as they stay together. So that can be done in 3 factorial ways, correct? So therefore, the total number of words in which consonants and vowels appear together is actually this. Now, if I want to calculate a numerical, that 2 factorial is nothing but 2, 5 factorial we all know is 120 and 6 factorial is 6. Therefore, the answer is 1440. Okay, so these many words can be formed. Okay, we did the same thing. We just separated vowels from the consonants, and then they are to be together. So we have considered them as one word. This is the one object. This second object. There are 2 objects. They can be permuted in 2 factorial ways. Among themselves, they can be like that. Okay, that is how we have solved these problems. Not very difficult problem. Okay, now, okay. Now here is another problem, third problem in the miscellaneous set of problems. A committee of 7 has to be formed from 9 boys and 4 girls. In how many ways this can be done? If, and there are 3 conditions and there are 3 problems. So let us do one by one. First problem is exactly 3 girls. Second problem is at least 3 girls. And the third problem is at the most 3 girls, right? So how many boys are there? So let us write down. Number of boys and girls. Okay. Now, number of boys are 9. It's given there. Number of boys are 9. And how many girls are there? 4. These many boys and girls are available. They are available. But I don't want all of them. Right? I want to create a committee which does not contain all. That means 9 plus 4, 13 objects are not required at all. We want only 7 people, right? So we want to select 7, right? 7 out of 9 boys and 4 girls. But what is the condition for the first problem? So first question is exactly 3 girls. Now, since you want exactly 3 girls, obviously you are going to select 3 girls out of 4, right? So 3 girls out of 4, and remaining have to be boys. And the committee contains 7 members. Out of that, 3 are girls. So 4 are boys, right? So 4 boys are to be selected. So 9 में से 4 boys select करना है और 4 में से तीन गर्ल्स को सिलेक्ट करना है. That can be done in how many ways? Obviously, it can be done in 9C4 ways, right? Multiplied by 4C3 ways. Okay. Now 9C4, 4 is already greater than the half of 9. So I'm not going to change this, but this is what this one I can change. So it is 9C4 and this 4C3 can be written as 4C1. Correct? Now it becomes easier for us to calculate. So it is 9 multiplied by 8 multiplied by 7. How many times? 4 times. So therefore this is 6 divided by 1 into 2 into 3 multiplied by 4. Correct? But 4C1 is very easy. You have to just take it 4 only because it has to be done only once. So 4 into 1. Okay. Now I am leaving the ultimate calculations to the students. This is how the problem can be solved. Okay. Now let us look at the second question. What is the second question? So second question is very interesting. At least 3 girls. That means the problem can be done in multiple ways. At least 3 girls means what? So either 3 girls and we want 7. Total number has to be 7. That means 3 girls and 4 boys. So 4 boys and 3 girls. That is one combination, right? But you cannot reduce the number of girls. You can increase the number of girls. How many girls are there available? Girls available are 4, right? So 4 girls are available. So I can increase one more girl. So 4 girls, and that means the number of boys will be reduced to 3. Correct? Can I increase the number of girls now? No, because the availability is 4 only. So I can either take 3 girls and or 4 girls. So either the job can be done in this way or this way. Correct? Now whenever there is or, you have to add, and whenever there is and, you have to multiply. So 4 boys are to be selected out of how many boys? 9, right? So that can be done in 9C4 ways. Girls can be chosen in 4C3 ways, right? So therefore, first job can be done in how many ways? 9C4 multiplied by 4C3. Okay? Plus, because the job has got alternative way of doing it, right? So you can select 3 boys out of 9 in 9C3 ways, and you can select all 4 girls. That can be done in how many ways? 4C4 ways. Okay. Now, what does that mean? As I said, this becomes 9C4, but this becomes 4C1. Okay. And this becomes 9C3. 4C4 is obviously 1. So let us write it as 1. Now it's very easy to calculate. So therefore, what happens here? If I want to calculate this number, it is 9C4. 9C4 means 9, go backwards, 8, go backwards, 7, go backwards, 6. How many times? 4 times. So 1 multiplied by 2, multiplied by 3, multiplied by 4, multiplied by 4C1. 4C1 is just 4. 4 upon 1 plus, there is additional answer, 9C3. 9C3 is what? 9 multiplied by 8 multiplied by 7. I cannot go up further because only 3 are allowed, and denominator is 1 multiplied by 2 multiplied by 3. So if you calculate, this 6 will get cancelled with this 6. This 4 also gets cancelled. So what is left here is 9 multiplied by 8 multiplied by 7. 6 is already gone. And here, if I take this 2 here and cancel it with this 4, so it becomes 8 becomes 4, and this 3 can be cancelled with this 3. So this becomes 3 multiplied by 4 multiplied by 7. So that means it is 56 multiplied by 9 plus 12 multiplied by 7. So that gives you this is the answer, the complete answer. Okay, that is a problem number 2. So we have solved this problem. Okay, still this problem is not yet over because there is a third alternative. At the most 3 girls. Okay, fine. So let us talk about that. Let us write once again. How many boys are there? There are 9 boys. There are 9 boys and 4 girls. Now at the most 3 girls. What does that mean? That means you are not allowed to take more than 3 girls. But you can allow to take less than 3 girls. So you can take 3, you can take 2, you may not take any girls, right? So the first combination is what? All 7 boys. 7 boys. Okay? No girls. 0 girl. Allowed. 6 boys. 1 girl. That is allowed. Okay? Then you can have 5 boys and 2 girls. And what is the condition? At the most 3 girls. So one more choices you have, that is 4 boys and 3 girls. You are not allowed to take more than that. Okay. So this is one way of calculation. But at the most 3 girls, so which means the problem can be solved in these many ways. Okay. So first answer is what? It is 9C7 multiplied by 4C0 plus 9C6 multiplied by 4C1 plus 9C5 multiplied by 4C2, then 4 multiplied by 4C3. That's all. So this is how the problem can be solved. Another way of looking at this problem is this, that you want at the most 3 girls, right? At the most 3 girls. That means which 1 girl is allowed, 0 girls are allowed, 0, 1, 2, 3 are combination allowed. What combination is not allowed? Only one combination is not allowed, and that is 4 girls, correct? So we can do this problem in a slightly different way, which will be easier to calculate, because you can see how many terms are there, 1, 2, 3, 4. So 4 terms you have to calculate, and obviously it's going to take a lot of time, because most of the problems will be asked in the form of objective questions, which does not have much time to solve, right? So let us see the another way of looking at this problem, okay? Same problem, we'll solve in a different way. Now, girls are allowed, but how many? At the most 3 girls. How many girls are not allowed? We'll calculate that, and that will subtract from the total number of combinations. So there are 9 boys and 4 girls, right? So 9 boys plus 4 girls. So total number of persons available are 13. And suppose there is no restriction on the collection at all, then how many committee you could have formed? Because you have to select only 7 people. So you could have done it in how many ways? 13C 7 ways. These are the total number of committees that can be formed without any restrictions. But one particular combination is simply not allowed, and that is what? 4 girls combination. Now if you select 4 girls, then there are 3 boys. So which combination is not allowed? So the combination which is not allowed has to be subtracted, and there is only one combination. That is what? Out of 9 boys, suppose you select only 3 boys, and out of 4 girls you select only 4 girls. This combination is not allowed, whereas these are the all possible committees, and this. So this calculation is much easier than the previous one. So say 13C7 can be written as 13 minus 7, that is 13C6. And here 9C3 will remain as it is, but 4C4 you all know is 1, right? This is quite easier to calculate. So therefore this will be what? This is, I don't know. You can calculate the numerical answer, or you can keep it like this, depending upon what kind of answers are given to you in the alternative. Okay, fine.